friends. Today we're going to talk about square roots. Specifically, what are they and what do we do with them? So let's draw a square root. If I have this symbol right here, this translates to square root of 4. Now, it looks like a division symbol, kind of like long division, but it has this little tail on it right here, and that tells me that it is a square root. Now, we have a number here that's implied. If you don't have a number, it is implied to be a 2. And what that means is this symbol asks the question, what number multiplies by itself to make 4? Okay? So when I see square root of 4, what that really means is, what do I multiply by itself to get 4? Well, we know that one. Square root of 4 is just 2, because 2 squared is equal to 4. And that one's pretty easy to see. Sometimes as they get bigger, it's a little bit more difficult. All right, so now that we know what a square root looks like and how we evaluate it, the next thing I want to talk about is what are the perfect squares that we tend to use most. And I've got a list of them that I want you to memorize. I hate to ask you to memorize, but unfortunately, that's the best way to do this. So let's throw them up on the board. All right, here are our list of the first 12 perfect squares. So let's look through them. If I take 0 squared, and remember that's from our exponent rules, we're going to see that square roots and exponents are very closely linked. So 0 squared is 0, 1 squared is equal to 1, 2 squared is 4. Those are pretty familiar. 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 9 squared is 81, 10 squared is 100, 11 squared is 121, and 12 squared is 144. If you think back to a multiplication table, these would be the numbers on the diagonal of your multiplication table. And these are very important in evaluating square roots. So some square roots are going to just involve a perfect square. Some of them will be a little more complicated. So for example, if I were to ask you for the square root of 81, it would be important to know the list of perfect squares and remember that 81 is 9 squared. So when I look for the square root of 81, well, what number multiplies by itself to make 81? It's just equal to 9. And remember that when we take the square root symbol goes away, and we just write the number 9. Similarly, if I were to write square root of 64, we'd ask ourselves, what number multiplies by itself to make 64? Well, 8 squared is equal to 64, so square root of 64 is just 8. What if I asked you for the square root of 1? That could be a little tricky. So what number multiplies by itself to make 1? Well, just 1. So the square root of 1 is 1 because 1 squared is equal to 1. All right, these were all perfect squares, and so we can evaluate them using our knowledge of the list of the first 12 perfect squares. If we don't have a perfect square, it gets a little bit more complicated. Now, we're still going to need this list, and I want to encourage you to practice writing this out until you can write it very comfortably with no help. This is something that you might want to write down on the side of your homework or possibly on a test to refer to. And we call that a brain dump, when we write down something super important before we start an assignment so that we can refer to it later. All right, we're going to look at a rule, and this is our rule for splitting up square roots. So if I have the square root of two numbers multiplied together, and we're just going to call those A and B. A and B are just any two numbers. We can rewrite this as the square root of A times the square root of B. This doesn't seem super earth-shattering here, but it allows us to evaluate some square roots that aren't perfect squares. So let me show you what I mean. We're going to throw some examples up on the board and we'll work through them. Here we go. All right, so when I look at square root of 40, first thing I want to do is think to myself, is 40 a perfect square? Which is where this list comes in really handy. Well, no, 40 is not a perfect square. So the next thing is to use this formula and break 40 up into two factors that multiply together, one of which is a perfect square. Now, there's a lot of ways to multiply together to get 40. So I might make a little list for myself out here. 40 could be rewritten as 40 times 1. Well, we've already decided that's not helpful, right? Because 40 is not a perfect square. We could write it as 8 times 5, which is true. But neither 8 nor 5 is a perfect square. But what if we wrote it as 4 times 10? That's helpful because 4 is a perfect square. So I'm going to rewrite the square root of 40 as the square root of 4 times 10. Now notice I didn't change anything. I just rewrote 40 as two things multiplied together. And my rule tells me that the square root of two numbers multiplied together is the same as the square root of the first times the square root of the second. So this would be the square root of 4 times the square root of 10. Now, why is that helpful? Good question. I know what the square root of 4 is. I can evaluate the square root of 4 because 4 is a perfect square. So the square root of 4 is just 2. See how we rewrote that square root of 4 as 2? And remember that when that square root is taken, when we do that operation, the square root sign disappears. Now, what about that square root of 10? I would want to ask myself if I could evaluate that any further. So what are the factors of 10? 10 and 1, 5 and 2. None of those are perfect squares. So that tells me I've simplified this as far as I can. And 2 square root of 10 is the most simplified form I can write this square root in. And it's okay to leave that square root of 10 exactly as it is. That's an exact answer. We don't want to put it into the calculator and get a decimal approximation. We want to leave it exactly as it is. Okay? It looks a little weird. That's okay. All right, so next, let's look at square root of 48. Again, what are the factors of 48? Let's write a table. So 48, let's see, that could be 6 times 8. It could be 4 times 12. It could also be 16 times 3. Now let's notice 4 times 12, well, that is a perfect square. And I could start there. The problem would work out just fine. I just would have one extra step. But 16 times 3 16 is my biggest perfect square. And so that's the breakup I want to deal with, 16 and 3, because it has the biggest perfect square. All right, so square root of 48, I'm going to rewrite this as the square root of 16 times 3, which would be square root of 16 times square root of 3. We know what the square root of 16 is because 16 is a perfect square. So I would rewrite this as 4 instead of the square root of 16. And then that square root of 3, there's nothing else I can do to it. So we'll just write it on the end. So my final answer would be 4 square root of 3. Now, I told you that if we broke it into 4 and 12, it would still work. I'd like to show you how. So if I rewrote this as square root of 4 times 12, this would be square root of 4 times square root of 12. And I could simplify square root of 4 to be 2. And then I still have that square root of 12. Let's think about 12. Does 12 have any perfect square factors? So 12 and 1, 6 and 2, or 4 times 3. Oh, there it is. I can break up 12 one more time and rewrite square root of 12 as the square root of 4 times 3. And that 2 on the front just stays with it. So I have 2 times the square root of 4 times 3. Let's rewrite this. This is 2 times the square root of 4 times the square root of 3. We know that the square root of 4 is equal to 2. So this is 2 times 2 times the square root of 3, which is 4 square root of 3. So notice, either way, we got the same answer. Now, I had to do a little bit more work here, and that's okay, as long as we recognize at this point, 2 square root of 12, that we're not quite done. All right, now, I did have square root of 12 here as an example. I think I'm going to jump over that since we just evaluated square root of 12. So we'll just fill it in for good measure. This would be square root of 4 times 3, which is 2 square root of 3. All right, next example, square root of 150. Well, let's see. 150, that has a lot of factors. So I probably would want to take a peek at my perfect square list and notice that 25 is one of my perfect squares. So 150 is 25 times 6. And you might use a calculator to do that, no problem. So 150 would be the square root of 25 times 6, which would be the square root of 25 times the square root of 6. And then the square root of 25, I'm going to rewrite as what it's actually equal to, which is 5. So we have 5 square root of 6. Again, notice that when we take the square root of 25 to get 5, the square root symbol comes off. All right, one more. Square root of 98. Now, in another video, I'm going to come back to these two problems and give you a different way to approach these square roots, especially when you get a number that you're like, I don't know what divides 98. I'm going to give you a way to approach that that's a little bit different. One thing we can do, though, is start checking to see which of these perfect squares divides 98. just using your calculator. So I might start with 9 squared and move down the line. And I chose 9 because 81 is our largest perfect square that is less than 98. If I did that, I would discover that 98 is just 49 times 2. And so square root of 49 times 2, well, we'll rewrite that as square root of 49 times the square root of 2. And we know the square root of 49 because of our perfect square list here. We know that that is 7. So square root of 49, I'm going to rewrite as 7. And then we have a square root of 2 on the ends. And of course, we would just want to leave that as it is. We can't multiply the 7 and the 2 together. And we don't want a decimal approximation, so we're going to leave it as that exact answer. In my next video, I'm going to give you a different way to approach square roots that is just an alternative if this method doesn't work as well for you.